Today we're going to continue to do a little bit of Grasshopper scripting and bringing that new representation form into Photoshop and After Effects for that added component. Again, I'm starting with the workshop file. Again, you guys will have your own site, but the principles should be the same for this. So a lot of you guys are looking into issues on stormwater. We've looked at the drainage conditions. Something that's also important for adding to that drainage patterns is contamination. So are there certain hotspots associated with your site that you want to include within that graphic visualization? There's a lot that go into the quantities of runoff volume, but there's also the quality concerns that are just as important. So we can start to indicate that as well in our After Effects video. So we're going to look at two different ways in which you can represent that fairly easily. Really, all you're going to need is to use that same surface that you've probably done your drainage patterns on. In this case, I just have this large parking lot. If I turn on this wallpaper, and give it more of a ghosted appearance, I can see. Let's go ahead and match it. And we'll just hide this for now. So looking at this screen, we can start to make some assumption as to where there may be some contaminant hotspots. Usually when you're dealing in parking lots or any areas that are influenced by a lot of automotive, you're going to have those types of contaminants like heavy metals and hydrocarbons, probably all collecting in this area since it's draining down. Maybe there's some other hotspots in there we can start to indicate. So something that would be nice is to visualize that or show that in the video as well. So we have that drainage pattern that's already flowing here. Then we show, oh, all that water is draining and picking up those contaminants and really having a negative impact on our water quality. So let's look into that now. So let's bring up that surface again. So I'm just going to simply select that surface, reference this in Grasshopper, and like I said, we're going to look at two different techniques, one being a mesh and one being a surface. Both have their own methods of looking at this essentially a hotspot. The mesh version is going to create more of a color gradient versus the surface is going to look a little more grid-like or kind of pixelated. Both have their own merits. It really kind of comes down to how you want your visualization to come out. So hopefully this gives you a better idea or some inspiration of how to start to visualize these contaminant hotspots. So for the first one, I'm just going to do it as the mesh. So I'll go ahead and turn this off. Go to my mesh and convert that in BWrap or surface into a mesh. So same thing that's going on. I'm going to go ahead and deconstruct this mesh. So now I have it all in series of vectors, faces. You can start to see how that looks on here. It just barely fit off the screen. There we go. So I'm going to turn this surface back on so I can snap to something. As mentioned before, there's probably a good contaminant hotspot around here. Let's assume that there's going to be one up around here as well where there's some parking. So all you have to do is start to place some points on the surface. We're going to do a distance mapping with these points. So here's this first point that I've already kind of snapped onto that surface. Then I have one off in this distance already. So what I'm going to do is I'm going to select these points and reference this in Grasshopper. So set multiple points. There you go. So you can see that they're being highlighted in the Rhino workspace as those green points. We can move them around too if we want. So this is basically going to be a distance mapping exercise or script. Let's go ahead and hide the surface now. So basically what I'm going to do is measure the distance of all these points on that surface or this mesh in relation to these designated hotspots for contamination. Again, you'll have your own site to discover or point out where yours is going to be located, but all you have to do is indicate those contaminated hotspots with a single point or multiple points in this case. So what we're going to do is go to the Vector tab, choose Point, and do Closest Point. You can see this component asking for a point to search from and cloud. This gets a little weird to remember. I always try and say, like, okay, this first input is basically the series of points that I want to measure in relation to specific points. So in this case, I have the contaminants, which go into here, and then the V is your vectors or your vertices into there. So it's basically here's all those points you're looking at versus those contaminant hotspots in this case. And the best way to figure out if that's working correctly is to go to your curve, do a line, and just drag this into here and this point into there. And you'll see through this graphic which points are going to one and then the other. That way there's no overlap that could mess with the script. Okay? Now again, that's just a reference. You can keep that component, so I'll just delete it. What we're really interested in is this output of distance measurements, basically using that distance to tell whether that area is going to be a vibrant color versus more of a muted to show that it's not having as much of an impact. So let's go ahead and turn this off. What's nice is this is going to be a fairly simple script too. So now I have to basically reconstruct this mesh. So I'll go to Mesh, Construct Mesh. I'm just plugging in the same variables, so vertices into the vertices, the faces into the faces. The next thing it's asking for is color, and this is where we're going to create a color gradient. So what we can do now is go to our parameters, pull out the color gradient. We see that it's looking for a lower limit, in this case the shortest distance, upper limit, the furthest distance, and then all the distances as that list. So I'll go to my math, choose the min and the max so I know what the closest and the furthest distances are. That'll create that domain. I can then deconstruct that domain. So I have, again, the shortest distance is 3.5 feet, the furthest one is 236. I'll drag those into these corresponding values. Oops. And then the last thing it needs to know is what all those distances are. So I can move these down a little and drag the distance of all those points into this t value. And you see it turns gray, which is good because that means it's working. Now I can drag this into the colors input here. There's something that's overlapping. Let's go ahead and think it's this one. Yeah. And the defaulted gradient isn't being that helpful. I would assume that the closer it's these points, the darker or more vibrant that color is, in this case this slider, versus this one's going to be our extreme. To change those, you can just right-click on these points and choose a color. I like my reds to be closer to the warm spectrum, so let's drag that a little bit dark. We can change that value a little bit darker. Commit change, and then I'll right-click on this one. Let's just choose a white. Commit changes. And you can see that you can start to see somewhat of those hotspots, but we can make that a little more drastic by dragging the slider over here. So now you can start to really see how those colors are responding to the proximity of those points. And what's nice, I'll just click back to my visualization here. I can see that it's starting to do something, but there's still some parts that I wish were a little better. You can see that the edges are a little pixelated. That's because when I look at this deconstructed mesh, the grid of points isn't that dense. It's very sparse in some of these areas, but that's pretty easy to do or to fix it. You'll see when I converted the surface into a mesh that there's also this settings input. If I right-click on that, say Set Mesh Options, and let's just increase the amplify value. In this case, I'm going to jump it up to around 8 or 10. So let's just go right up to 10, hit OK. Now you can see my grid of points is much more dense. And then when I turn this off, you can see that those hotspots are actually treating more like a circle, which, I mean, kind of depends on you. Maybe you like that more pixelated, abstracted form, or maybe you want something that does a better job of fading. That's up to you, but now you know how you can start to control that. If I go back, maybe change that to a 5. Okay, so that starts to get it right in that middle of being somewhat flush, but also a little bit of pixelation. That looks kind of cool, actually. And unfortunately, the meshes don't respond well to transparency. So even if you try and do that, unless you start to get some of those plugins, you can play with that. But for the purpose of this, it's going to have a solid color, no matter what. But the other benefit of this is that you can actually bake this mesh with the color itself. So let's go ahead and turn this off. I'm going to bake this onto a layer. This one's pollutants /M for mesh. Hit OK. So it's turned off, you can see. But in the Rhino space, it's actually there with the color. If I change my viewport to a rendered, it'll get rid of those curves. You can see, like, if I drag that, it drags it with the colors. So that's kind of nice that you can actually have the colors baked from a mesh into your Rhino workspace. Meshes are the only way you can transfer. I mean, you can with some of those other plugins, but you can't have transparency. That's the drawback to it. But the other option, you can start to achieve that. So again, I'm going to set that view. I'll turn off. Let's just keep that one turned on, and let's turn off everything else. The point is that now you can go ahead and go to View. You could render this, or you can just do the Capture option to save that as an image. That way, you can bring that into Photoshop and After Effects to start blending it a little better, because obviously you aren't going to see some of these things because of the cars and the sidewalks. So keep that in mind. So the other option that we can do is take on more of a grid format. So let's go ahead and turn off this mesh. So in this case, I'm going to take this surface and I'm actually going to divide it into a grid. The easiest way with some of the default settings is going up to domain squared at the very bottom, drag that into there. I'm going to do a number slider of 10, less than 50, because I don't need it to be that dense. both the U and the V values since the parking lot's already pretty much square, so those constraints can stay the same proportion. Next thing I'll go to is the Surface tab, choose Utility, and then choose the ISO trim component. This is going to take that surface and divide it based off of that domain value. So in this case, 10 by 10 grid. Again, nothing fancy. If I change the slider, that grid will be more dense. So again, it's all depending on the value you want to set it at. I'll keep it at 40 just because I can hear my fans on my laptop start to get a little overwhelmed, so I don't want to push it too far this week. So we can go ahead and drag that. So again, the same thing we're going to do is use this distance measurement part of the script. The only thing we need still for this is the points associated. What's nice is that these are all their own individual cells, so from that I'll turn that off and I'll do an area component. Hit the center point of each one of these cells. So take a second. So same thing, it's just a grid of points, so turn that off. And so now I'll just go ahead and copy this part of the component from the previous part. But now I still have those same points are going to be the same. The only thing that's changing is the points that it's searching from is going to be these center points. So I have that. And now what I want to do is actually apply that color to these surfaces. So you go to your display, so I'll just do custom preview, grab that component. The things that we're going to try and color are these subsurfaces or those cells of the grid. So I'll drag that in as my geometry. For some reason, defaults it to pink every time. It's clearly not the color we want, so in this case, as that shader input, here I'm going to choose my color gradients. Now as you can see, it does the same exact thing, but in this case it is more of a grid format, which again has its own merits, but the other thing that's cool about this is that I can show transparency to it. So if I right click on this white value, so it'd probably be good to keep the red a solid color, but then the way as it gets further away it becomes more opaque. So if I go to my alpha channel and drag that down, commit changes, you can start to see how that transparency is actually showing up. You can take this a little bit further. Again, this is a very planar visualization. The grid's probably even a little too big for this instance because when you start to put it in that perspective, it's a little too large for my interest. But just like this, you have these cells. You could even start to have them extruding up to maybe give it that added depth or robust quality to it that can show that visualization a little bit more clearly. You can animate it based off of the last assignments and those fundamentals, but the idea is that you can integrate now some of those contaminant hotspots to your design. Okay?